Hi, Red Knights. We are here with another lesson on electricity. Today we're going to focus on static electricity. Let's hop on over to our science textbook to learn more about static electricity. Electricity and magnetism. Electrical energy. Matter is made up of very tiny parts called particles. These particles have either a positive or a negative charge. Electrical energy is the energy of these charged particles. Electrical energy. You sometimes feel a shock when you touch a metal doorknob. This shock occurs because of electricity. If the room is dark, you can see a quick spark of light with the shock. A flash of light and the glow of a light bulb also occur because of electricity. The property of matter that causes electricity is an electrical charge. You cannot see electrical charge, but you can understand how objects with different charges interact. There are two types of electrical charges. One is called positive. The other is called negative. The diagram below shows how objects with positive or negative charges affect each other. So as it explained, you can't see electrical charge. So they're using this diagram to demonstrate what electrical charge does. To do that, they're using red circles with the minus sign inside of it. So like it explained, you can't see an electrical charge, but they are using this diagram to demonstrate what electrical charge does. To help us understand, they are demonstrating positive and negative charges with these circles. To demonstrate a positive charge, they are going to use a blue circle with this plus sign in the middle to show a positive charge. To demonstrate a negative charge, they're using a red circle with this minus sign inside. This is to represent a negative charge. The diagram says an object with a positive charge pulls on an object with a negative charge. So we have the positive charge and a negative charge. And when you have two of the opposite types of charges, they attract, they pull together. Objects that both have a positive charge push each other away. So these are similar charges. They're both positive charges, so they are pushing away from each other. They are repelling. Objects that both have a negative charge also push each other away. So here we see similar charges. They're both negative charges. And since they're both the same type of charge, again, they're repelling each other away. So what this is saying is opposites attract. So if you have two different charges, they attract. But if you have the same types of charges, they repel. Static electricity. All objects are made of charged particles. Most objects have the same number of positive particles and negative particles. The charges are balanced. When two objects touch, negative particles can move from one object to the other. Negative particles may build up on one object. That object has a negative charge. A buildup of electrical charge is called static electricity. A discharge occurs when static electricity moves from one object to another. This movement is why touching a doorknob can sometimes produce a shock. As a person walks across a floor, negative particles move from the floor to the person. These negative particles move to the doorknob when it is touched. The lightning strike is an example of a very large discharge. Caption: You feel a shock when electrical charge moves from a doorknob to your hand. Caption: Lightning occurs because of a buildup of electrical charge in clouds. When you rub a balloon on a sweater, negative particles move from the sweater to the balloon. Then, if you hold the balloon near a wall, the negative charge attracts the positive particles on the wall. This attraction causes the balloon to stick to the wall.
The buildup of electrical charges on an object is called static electricity. Rubbing objects together causes them to touch in more places. It produces more static electricity.
Let's take a look at this example of this balloon and go through the steps of what happens as you create electrical charge on a balloon.
A balloon and a wool cloth are neutral. Each has as many negative charges as positive charges. By rubbing the balloon with the wool, negative charges build up on the balloon. The negative charges on the balloon attract the positive charges on the wall. The balloon sticks to the wall.
Now that we learned about these negative and positive charges and how they can create static electricity to cause a balloon to stick to a wall, let's hop over to the simulator and try it out for ourselves. We have a static electricity balloon simulator. Here I have a balloon that is neutral. It's neutral because it has the same number of negative charges as it does positive charges. Do you see how there's 4 negative charges and 4 positive charges? That means it's neutral. This balloon is neutral, this sweater is neutral, and so is the wall. Let's see what happens when I put the balloon to the sweater. It's picking up the negative charges from the sweater. So the negative charges that are on the sweater are being transferred to the balloon. Let's see what happens when I pull the balloon away. The balloon is attracted back to the sweater. Let's see what happens when I rub the balloon on the sweater. Do you notice what's happening? The balloon is collecting all of the negative charges from the sweater, and the balloon is now stuck to the sweater. If I pull it back, let's see what happens. Did you see how much faster the balloon attracted to the sweater with that many more negative charges attached to it? Let's see what happens when we take this negatively charged balloon over to the wall. Do you see how the negative charges are repelling away from these negative charges? That's because when you have 2 of the same type of charge, they push away from each other. They repel. Watch how it repels all of these negative charges. Let's reset so everything's back to neutral. You can experiment with this simulator and try giving it one rub to give it a little bit of charge, or several rubs to give it a greater charge. You can even go and select 2 balloons and experiment with those and see what happens if you charge both balloons. I want you to think like a scientist. Ask questions and see if you can explore and experiment to get answers. All right, my third grade scientists, that's all for our lesson today. Bye for now.